Hello, this is question 9 on your November 2020 paper 2 from AQA, and it's a differentiation question that looks more difficult than it is. So you have a cylinder is to be cut out of the circular face of a solid hemisphere. The cylinder and the hemisphere have the same axis of symmetry, and the cylinder has height h and the hemisphere has radius r. You have to show that the volume of the cylinder is given by this formula and is in terms of r and h. So this r and this h. And I've done already a sketch of a cut of the cylinder and the hemisphere because I think it's going to help you. So the dimensions that we know is this radius here. So this is r and this is h, this distance here. And we need the area of the base of the cylinder to multiply by the height to have the volume of the cylinder. So the volume of the cylinder is going to be the area of this circle times by this h. So we need the radius of this circle. So if I call it, for example, r, a small letter, we need that r, this r. So what we can do is, this length is the radius of the hemisphere, yeah? So this is r, capital letter R. Sorry. This is r. So we can use this triangle. I don't know if you can see this triangle, which is a right angle triangle, where we know that one side, this is h and this is r. So we can find, as it's a right angle triangle using Pythagoras, we can find this r in terms of r and h. So using Pythagoras, r squared is going to be r squared, capital letter, minus h squared. Yeah, and I'm going to leave it squared because we are going to use a squared in the formula. So the area of the cylinder is going to be the area of the base, so pi radius square, and the radius is that r times by h. And we have that radius in terms of the radius of the hemisphere and h. Yeah? So when we multiply, we have pi r squared h minus pi h cubed. That is precisely what we have here. Yeah. So this is the first part. Then for the second part, which is the longest, it says find the maximum volume of the cylinder in terms of r. To find the maximum volume, we are going to differentiate. So we are going to differentiate our expression of the volume with respect to h. We could do with respect to r and then substitute equally, and you will get the same answer. So you have this is your expression, and even if you are not able to deduce it in part A, you still can use it because it's given here. So we are going to differentiate that with respect to h. So we have pi r squared is the first part, so pi r squared, and then second part I have h cubed, so it's going to be 3 pi h squared minus 3 pi h squared, and this must be 0 to be a maximum or a minimum, which means that r squared, we are going to leave it in terms of r. So the one that I'm going to make the subject is going to be h. H is going to be r h squared. I'm going to do h squared first. R squared divided by 3, which means that h is r divided by root 3. If we go to the volume formula that we had before, we have the volume is going to be pi r squared h, so pi r squared h, and instead of h, I'm going to write the expression that I have for h, and I just found root 3, minus pi h cubed, so minus pi h cubed. And this is going to be pi r cubed divided by root 3 minus pi r, sorry, this is 3, not 2, r cubed divided by 3 root 3, which is root 3 to the power of 3. This is going to be by r cubed divided by root 3, and 1 minus 1/3 is 2/3, yeah? So times 2/3. I'm just factorizing, so if you want to add one step, I'm just factorizing, so I have 1 minus 1/3, which is 2/3. So I have 2 by r cubed divided by 3 root 3. And if you want, I think it looks better if you rationalize the denominator, multiplying and dividing by root 3. So I have 2 root 3 by r cubed divided by, I have 3 times root 3 root 3. So these 2 root 3 becomes 3 times 3 is 9. Yep, and this is the maximum volume. It says fully justify your answer and it's 7 marks, which means definitely you have to check is a maximum for what we are going to derivate again. So again, with respect to h, so we are going to differentiate this expression. This one, when we differentiate with respect to h, is 0. This one is going to be 2 times minus 3 is minus 6 by h. And when we substitute this value here as an h, not this value, sorry, this value of h, the expression is going to be negative, yeah, because the h is a distance, is positive, so this is going to be 0, which means that is a maximum. And that's the only thing that we need to do to check, yeah. And that's all with this question. So we found the maximum value of the volume, so this is maximum volume, and we have justified that is a maximum. And that's all with this question.